There are several ways on how we simplify trigonometric equations, and the key here is you need to be familiar with your trig identities. And there are tips on using the trig identities so that you can simplify a trig equation or a trig expressions. So the first one is you need to start on a more complicated side. So if you have a trig function, you need to check whether you can work out the first term or the second term, and you'll see that in our examples later on. Also, it is easy to change all your trig functions into sines and cosines, and that is my step number 2. And once again, the most important step is you need to be familiar with the trig identities. And also, in algebra, you need to remember your factoring rules because this is essential in learning or understanding how to simplify trigonometric equation, and that you can visualize a trig function into an algebraic expression, because it will greatly help if you can see and understand the connection between a trig expression and an algebraic expression. And here are my examples on how to simplify trig expressions. On the first one, I have tangent x cosine x, and by following my second tip, I'm going to change my tangent x into sines and cosines. And using the trig identity, tangent x is equal to sine x over cosine x. That's why I changed tan x into sine x over cosine x, and in the process I could eliminate cosine x and cosine x by canceling it. Therefore, sine x is left, and we know that tangent x cosine x is simply equal to sine x if we simplify it using the trig identity. And that's how simple trig identity is. Now, it will get complicated as our trig expression becomes more complex. Now, for number 2, I have secant x all over cosecant x. And just like what I did on the first example, I'm going to change all my trig functions into sines and cosines. So on my numerator, secant x can be simplified or can be changed into 1 over cosine x using the reciprocal identity. And for cosecant x, I can change it into 1 over sine x, therefore giving me a complex fractions. So by simplifying a complex fractions, simply copy the numerator and then take the reciprocal of your denominator and then proceed to multiplication. So that's why I have 1 over cosine x times sine x, which gives me sine x over cosine x. And we know from our trig identity that sine x over cosine x is simply equal to tangent x. So this particular expression or trigonometric expression can be simplified into tangent x. Now for my third example, I have cosine squared x minus sine squared x all over cosine x. Now, in this case, my numerator is the more complex trig function, and I'm going to simplify it using the Pythagorean identity. So I know that cosine squared x minus sine squared x is equal to 1 from my Pythagorean identity, so I can change the numerator into 1, leaving me with 1 over cosine x. And from my reciprocal identity, 1 over cosine x is simply the inverse of secant x. Therefore, this complex fractions right here can be simplified into secant x using our trig identity. And for example number 4, I have cosecant squared x times cotangent x minus cotangent x. I'm going to use my factoring rule or my factoring technique on how to simplify this expression. And in this case, my first term and my second term has a common factor, and that is cotangent x. So I'm going to pull out my cotangent x in my expression, leaving me with cosecant squared x minus 1. Now that I have cosecant squared x minus 1, since I'm familiar with my trig identity, I know very well that it's a Pythagorean identity that I could change into cotangent squared x. So now I have cotangent x times cotangent squared x, and by multiplying them together, because they are like terms, I'll have cotangent cubed x in my simple expression. So therefore, cosecant squared x, cotangent x minus cotangent x, can be simplified into cotangent cubed x. Now, not only that you need to be familiar with the factoring techniques used in the trig identities, you also need to be an expert or at least comfortable in dealing with fractions, because you will see fractions in trig expression or trig identities. So here, I have secant t all over tangent t minus tangent t all over 1 plus secant t. Now, in subtracting fractions, here is the general form on how you can subtract or add fractions with different denominator. So in this case, a over b plus or minus c over d can be simplified or combined into b times d, multiply the denominator, and then multiply dA plus or minus, depending on the operation that is being used, times b over c. And we will apply this general form of simplifying fraction in our expression. So in this case, I multiply the denominator. That's why I have tangent t times 1 plus secant t. I multiply 1 plus secant t and secant t. And I multiply tangent t and tangent t. So now I have two terms separated by subtraction because our fraction is subtracting the first term and the second term. Now by simplifying it, I'm going to simplify my numerator and I will leave my denominator as it is. Because in this process, by distributing secant t to 1 and to secant t, I'll have secant t plus secant squared t. And by simplifying these two terms, multiplying them together, I'll have tangent squared t, separated by subtraction. And I left my denominator as it is because I know that I'm going to cancel it later on. So it is an important tip that you don't get crazy on simplifying a fraction. So try to minimize your fraction step by step by just simplifying the numerator first and leaving the denominator, and see what you can cancel in the process. So I would suggest that don't combine your denominator or simplify your denominator by combining them together, because eventually you might be able to cancel it. And that's what happened on my step right here. Aside from the fact that you should be able to be familiar with the identity, you should also be quick on identifying how you can play with the expression. And in this case, although it is not obvious because there's no parentheses, I know very well that I can combine secant squared minus tangent squared because it is one of the Pythagorean identity. So it is also important that with practice, you'll be able to be familiar with how to spot a certain term that you can combine for you to be able to simplify it. And that's what I did here. So I have secant t plus 1, because from the Pythagorean identity, secant squared t minus tangent squared t is equal to 1. All over tangent t times 1 plus secant t. And just like what I've been mentioning a while ago, I did not simplify by denominator because I know that I'll be able to cancel it eventually. And that's what happened here. Secant t plus 1 is the same as 1 plus secant t because their addition is commutative. So either way, you can cancel this term, leaving you with 1 over tangent t. And you know that 1 over tangent t is equal to cotangent t. So this complicated fraction right here can be simplified into cotangent t if you follow the process and if you are familiar with the trig identities. So now I have 2 cosine x plus cotangent x. And just like what I said, on tip number 2, I'm going to change all my terms into sines and cosines, and that's what I did here. I changed cotangent x into cosine x all over sine x. Therefore, I have a fraction here that I can combine by addition, and using my general form, I combine sine x and 2 cosine x, and combine 1 and cosine x in my numerator, and in my denominator, I simply multiply them together. And by combining these two together by multiplication, I have 2 cosine x sine x plus cosine x. And by factoring method, I could factor out cosine x because it's a common term or a common factor for both terms. So leaving me with cosine x times 2 sine x plus 1 all over sine x. And using the rule of simplifying fractions, I know that I could change cosine x over sine x into cotangent x, leaving me with cotangent x times 2 sine x plus 1. Therefore, 2 cosine x plus cotangent x is also equal to cotangent x times 2 sine x plus 1.